Hello, I'm recording the video and today's topic is testing. What is testing? Testing is the practice of making objective judgments regarding the extent to which the system meets, exceeds or fails to meet stated objectives. What the purpose of testing? There are two fundamental purposes of testing: verifying procurement specifications and managing risk. First, testing is about verifying that what was specified is what was delivered. It verifies that the product meets the functional, performance, design, and implementation requirements identified in the procurement specifications. Second, testing is about managing risk for both the acquiring agency and the systems vendor, developer, integrator. The testing program is used to identify when the work has been completed so that the contract can be closed, the vendor paid, and the system shifted by the agency into the warranty and maintenance phase of the project. Why is testing important? A good testing program is a tool for both the agency and the integrator supplier. It typically identifies the end of the development phase of the project, establishes the criteria for project acceptance, and establishes the start of the warranty period. When in the AC life cycle does testing occur? In the system engineering V model for ITS, testing is the first step in integration and recomposition. However, while testing is shown as one stage of the life cycle, it is important to understand that testing is also continuous process within the life cycle. Testing begins with writing the requirements. Each requirement must be written in a manner that allows it to be tested. During the design stages, testing will be a consideration as design trade-offs are evaluated for their ability to satisfy the requirements. New requirements may emerge from the designs as choices are made to satisfy the requirement within the project constraints. Hardware components, software components, subsystem and system will be verified during the implementation and testing stages. Final system level test will be performed to accept the system and demonstrate the system's readiness for production services. However, testing activities will not end once the system is in operation. Testing will continue as the operation and maintenance staff perform connective, adaptive, and other system maintenance activities. What methods are used to conduct testing? There are 5 basic verification methods as outlined below. Inspection. Inspection is the verification by physical and visual examination of the item, reviewing descriptive documentation and comparing the appropriate characteristics with all the reference standard to determine compliance with the requirements. Second, certificate of compliance. A certificate of compliance is means of verifying compliance for items that are standard products. Signed certificate from vendors state that the purchased item meet procurement specification standards and other requirements as defined in the purchase order. Records of tests performed to verify specification are retained by the vendor as evidence that the requirements were met and are made available by the vendor for purchase review. Third, analysis. Analysis is the verification by evaluation or simulation using mathematical representation, charts, graphs, circuit diagrams, calculation or data reduction. This includes analysis of algorithm independent of computer implementation, analytical conclusion draw from test data, and extension of produced data to untested condition. Fourth, demonstration. Demonstration is the functional verification that a specification requirement is met by observing the qualitative result of an operation or exercise performed under the specific condition. This includes content and accuracy of displays, comparison of system outputs with independently derived test cases, and system recovery from induced failure condition. Fifth, test. Formal testing is the verification that a specification requirements has been met by measuring, recording or evaluating qualitative and quantitative data obtained during the controlled exercise under all appropriate conditions using real and or simulated stimulus. This includes verification of system performance, system functionality, and correct data distribution. What is involved in a hardware test program? In general, the hardware test program can be broken into some phases as described below. Prototype testing. Prototype testing is generally required for new and custom product development but may also apply to modify product depending on the nature and complexity of the modification. Design approval testing. Date is generally required for final pre-production product testing and occurs after the prototype testing. The date should fully demonstrate that the ITS device conforms to all the requirements of the specification. Factory acceptance testing. FAT is typically the final phase of vendor inspection and testing that is performed prior to shipment to the installation site. The FAT should demonstrate conformance to the specification in terms of functionality, serviceability, performance, and construction. Site testing. Site testing includes pre-installation testing, initial site acceptance testing, and site integration testing. This test for damage that may have occurred during shipment demonstrate that the device has been properly installed and that all mechanical and electrical interfaces comply with requirement in other installed equipments at the location. Final acceptance testing. Final acceptance testing is the verification that all of the purchased units are functioning according to the procurement specification. After an extended period of operation, the procurement specification should describe the time frames and requirements for final acceptance. In general, final acceptance requires that the device be fully operational and that all deliverable, for example, documentation, training, have been completed. Thank you.